Dash is a unique evolutionary cryptocurrency that works different from many of its contemporaries. It has evolved significantly since its inception and now includes two separate blockchains, one for payments and another for data. Let's look into how Dash's unique system works under the hood. First, how do major blockchains like Bitcoin work? Let's start with Bitcoin and other derivative coins. With Bitcoin, the network creates a string of blocks, one every 10 minutes. When you submit your transaction to the network, it goes into the mempool, a sort of waiting area where transactions wait to be included into blocks. Transactions that came first, but especially those that pay more, get higher priority to get into a block. Miners compete to claim and get paid for processing blocks and for including transactions in a block. If there's a conflict where the same transaction tries to go to two separate places at once, that's called a double spend. Only one version can eventually make it into a block, usually the one with a higher fee. Until a transaction makes it into a block, you cannot be 100% sure that it's finalized. Sometimes, even after a transaction is in a block, it still won't be final. The chain with the most mining power wins out, and sometimes the rest of the network does not know about the longest chain right away. When they do, it overrides the other chain and can reverse some transactions, either purposely in a 51% attack, or accidentally when a block occasionally gets orphaned. This is why it's a good idea to wait a few blocks until considering a payment final. It never truly is, but the probability that a payment will be reversed after a few confirmations is extremely low. This is probabilistic finality. Ethereum and many other popular proof-of-stake coins work similarly, except with staked validators instead of miners. And many have different block times and sizes. Dash's system works like Bitcoin, except for the addition of masternodes. There's two types, regular and evolution masternodes, or Evo nodes. Through a function called instant send, groups or quorums of masternodes instantly lock in transactions and prevent them from being double spent, essentially guaranteeing them a place in the block. Another function, called chain locks, makes the first seen block permanent as soon as it's mined. If someone tries to double spend a transaction, it immediately gets rejected before even reaching a miner. Similarly, if someone mines a separate chain in secret, it will get rejected as soon as it's discovered, as it conflicts with an existing chain-locked block. Both these functions provide deterministic or absolute finality. There's no chance of transactions being reversed once locked in, unless the network itself is destroyed. With the launch of the Evolution platform in 2024, there's now a second chain as well, focused on data transactions. It's run purely by Evo nodes, which bridge Dash from the payments chain to Dash credits on the data chain. Dash transactions are processed by the Evolution chain, which do things like write or modify data in storage. This segmented approach uses miners, masternodes, and Evo nodes to keep both chains with very different use cases operating at peak security and performance. If any of these three elements fails or is attacked, the rest of the network can work normally. This unique setup makes the Dash network extremely secure, robust, and useful for a wide variety of applications.